Okay, this is Linux, Chapter 2, Part 2, and then we're going to talk about using paths, path names, and prompts. I need to kind of hurry through this. This is the third time I've created this particular video. The last one ran too long, so there's a lot to say. I'll kind of work through this in brief. We're working with absolute paths and relative paths in Linux. Now, an absolute path begins at the root level and is listed. Okay, when you see it, it's listed. Begins at the root level and lists all subdirectories to the destination file. Okay, so let's look at that quickly. And let's go through what we have here and find it. I'm going to clear this. Alright. Clean up something that I'm going to use later. Okay, now change directory / that takes us clear back to the root level directory, and we can see that at this point. Now an absolute directory, if we go to an absolute path, is when I go cd space / home / se scott. So every folder has to be, or directory has to be included in the path, and that is an example of an absolute directory. Now a relative path, I should be able to go cd space, take me back to the same place. Now cd space home is an example of relative. cd space se scott. So I'm setting my path based upon where my current home directory is, or where my current default directory is. Okay, so that's an example of a relative path. Now what we see here are a couple of examples though. cd space .. /source. I'm not going to use that example exactly because I was having some problems with my bash shell, which is, the bash shell is kind of the program that I'm working within that rides on top of that Unix engine. I need to log out and log back in to make that work. Now the other example, when you're using relative paths, being relative to your current position, I'm in the se scott folder, so if I cd space .. now that'll take me back up to the directory just above mine. cd space se scott, and that'll take me to the directory below it. So I'm using relative paths in this case. Remember, the entire absolute path is denoted by all the directories within that particular setting of your default directory. Okay, then we'll go to here. Now a directory is a special kind of file that can contain other files and directories. So we see this top level directory, we've looked at that before, and then you have home, and then your users, Jean, Tricia, and Joseph in this case. And this is just the example out of the book with directories below that. So Jean is a subdirectory or a child of the parent home. Source is a subdirectory or a child of the parent Jean. Now when we look at this also, we're looking at partitions. This is kind of bouncing around. I should add this to the next slide. I'm going to bounce just a little bit, which is normal, isn't it? The next slide says to change your prompt to display the directory you're working in, type in ps1 equals quote $pwd greater than single quote again. This slide will help demonstrate or points out the specific parts of what this particular first part of the slide is talking about. Then we'll bounce back to the partition. So this command to change your prompt is very useful in understanding where you are in working with directories. At this point in time, if you haven't changed that command, you have a prompt that looks like something like your username sescott@umhlinux, and that just really isn't very helpful most of the time. To change this prompt, I'm going to go back to Linux. Now I've already set that prompt, but you would type it in as ps1 caps equals single quote $ capital PWD greater than, and single quote again. I didn't get that single quote. Okay, and then that command will go ahead and change your prompt to a similar syntax. All your absolute directory structure will be pointed out within this prompt. Okay, now if we're looking at this dir, we're looking at bin, boot, device, etc. That's from the root level directory. Okay, we see bin, boot, device, etc. Okay, that's that top level directory, and when we type in the command dir, that's what we see. Next, we want to go and we can point out that I'm substituting SE Scott within the home directory. So let's go to the home directory. Okay. Here I'm seeing SE Scott, and within this listing I see SE Scott. That really points to the second level. Okay, when I go to then, what I can see is my home, SE Scott. So what I'm looking at is the home, the user, and then now I can look at the next level. And I can see spreadsheets, for instance, as a directory. Okay, now we see what my prompt is, and we can see where we are. Now I'm substituting spreadsheet instead of source. So I'm looking at home, the user level, and then the files within the user level. Again, remember that you need to change your prompt. So at the command prompt, just type in this command. It has to be uppercase, and you'll be able to see a prompt that looks more like this and probably more helpful. Now, listing directories and contents. With any command, there are a number of options that you can use with that. -L to view detailed information, -S to sort by size of file, -X, capital X, to sort by extension, -R in reverse order, -T sort the time when the directory was made, -A to show hidden files, and -I is what we've done already to show the inode value. So if we look at this, and I need to set my directory back up again, dir, so if I go now, and I just use dir instead of list, R in reverse order. Now notice I have zoo unique at the bottom. I should see zoo unique at the top. If I want to list it out in a sort of a dir sort of fashion, I use a -L. I can combine commands with -L and -R, so that as I scroll back up, the first file that I see is zoo unique. Okay, so that's how you use that list command. The next, okay, and then what do we see when we use that list command? So the first column is the access permissions, the file type and access permissions, number of links, the owner, the group that owner fits in, the size of the file in bytes, so 4096 bytes is actually 4K, the date of modification, and then the file name. So if we go back to this picture, we see what the permissions are. And this first set, and we'll talk about this in more detail, is the owner, group, and other. Okay, so that denotes the permission set. The user, the group, the file size 228 bytes, which is really small, the date of last modification, and then the file name. Okay, using wildcards, ls space star.txt will give you multiple combinations of characters, and then the question mark will replace a single character. So if we take a look at this, let's go in here. We have a number of different C files in here. So let's look at dir star.c, and that gives me a listing of all the C programs that I've developed, or that you will develop in this course. Now let's take a look at all the chapter. What do we want to look at? DRZ star gives us all the zoos. Now let's look at all the zoo question mark files. Now the zoo question mark should give us zoo, starts with zoo, and 1, 2, and 3. Sometimes you have to kind of experiment a little bit to make sure you get the command set right. So it actually did it. The command that I was using was supposed to give this kind of output. You know, sometimes you just have to work with it a while to get that syntax right. These are syntaxes, these are things, command sets that we don't use every day. But as an administrator, Linux administrator especially, and working within Linux, you will use it quite a bit. Okay, so that gives us the wildcards. The next will be creating and removing directories. So mkdir creates a directory, rmdir removes one. Okay, so I'm going to go mk, let's clear this screen. So mkdir test. Now that created the directory. Let's look at the directory, a list of directories, and at this point we see test. Okay, now rmdir test should remove it. We'll verify that. No test. Okay, now what I'm going to do at this point is let's see this. I'm going to demonstrate the rm-r to delete a directory that's not empty. So I'm going to go ahead and create a directory again, mkdir test, change a directory into test. I'm going to copy using cp and an absolute path. Let's see, home, S.E. Scott. I think there was a zoo3, and I'm just going to call it zoo3 in this directory. Look at my directory, so I have zoo3 listed. Okay, change directory out of test, and a lot of this is really cryptic, and it just takes some working with. It is what it is, and just remember that copying files is way easier using a GUI interface, you know, like the GNOME shell that Linux uses. Just keep in mind that oftentimes you can't do a lot of batch kinds of commands through the command prompt, or through the GUI interface. You have to do batch commands where you may be copying 100 or 200 different kinds of files from one directory to another through a command prompt. So just keep in mind that this is cryptic, but it is what it is, and often Linux administrators use this, especially for batch types of commands. Adding users is another one. Okay, so we are trying to remove directory test. We've created the directory, we've copied a file. We are trying to delete the directory, and it says directory is not empty on the right. So rm-r, which will just wipe anything, and that's something we want to be really careful with, obviously, especially as an administrator. Just us messing around is not a big deal. Remove rm or rm --r test. We'll look at our directory structure, and we'll see that there is no test out there. Okay, now let's go ahead and the final thing to discuss really is, and I guess we don't need to do this. We've copied a file already. Using that syntax. Okay, that's okay. And then we've tried to remove a file. Okay, to simply remove a file by itself, just type in rm. Oh, okay, rm and then the file name. So in this case, if I use sorted, and I use this because I think sorted, because I think this is a file I'm probably not going to use later on. rm --sorted, just to look again to verify it. It was between sort1 and spreadsheets, and is no longer there. So that